Hi friends, we're going to talk about some circle formulas today, and I'm kind of assuming, but we probably need to review, that you remember some circle formulas from back in the day. For example, the area of a circle, area squarea, is pi r squared. And the circumference, the total distance around the edge, is, I've always been kind of a 2 pi r kind of a girl, but if you know that 2 times r, 2 radiuses make up the diameter, some people like to use pi times d for the circumference, and both of those would be correct for circumference formulas. And the new thing that we're going to talk about today is sectors of a circle, which is just a section of a circle, and it's divided out so that you take the center and you cut out a slice, right? And so this sort of Pac-Man looking thing is called a circle sector. And we're going to talk about how to find the area of that and how to find the length of this arc, which is kind of review for us, but we're going to talk about it again. And it basically just means that we're going to be taking a fraction of the total area and the total circumference. So that's the main idea of today's lesson, is taking a fraction of those. The one that we did just a couple weeks ago, finding the arc length of a sector, because we were talking about arcs when we were learning about circles, and we learned that the measure of this arc, the measure of arc AB, is 100 degrees, because the central angle is 100 degrees, so the measure of the arc is 100. But then we need to talk about how long that arc is too, because it has a length. It's sort of a curvy length. And if you look at these 10-inch radii, you could think, okay, well, maybe that's a radius and a little more. I'm not sure. So remember, what we're going to do is to think about the length of that arc. Maybe I'll call it L. Sometimes it's called S, just FYI. We are going to take some certain fraction of the total distance around. And the total distance around is the circumference. So I usually use the 2 pi r. And about that fraction, how are we going to figure out what fraction of the circle that is? Again, we're just going to think of, in degrees, the whole circle is 360 degrees. And we are just finding 100 degrees of that. So that's how we find what fraction of the total circle that is. So in this case, r would be 10. So we're going to take 100 over 360 times 2 times pi times 10. Make sure you're using the pi button on your calculator. We don't need any extra rounding errors. We're going to have to round all of these. This one's coming out for me to 17.453. And since that's a length, that would be in inches. You'd need a bendy ruler to measure that, but that's what that stands for. And so the formula here to find the arc length is we take the measure of the arc over 360 times 2 pi r. That's the formula you can just always use for arc length. Finding the area of a sector of a circle, which just follows that same plan as the arc length. We are going to find the area of that sector by taking a fraction of means times, of the total area. And the total area is always pi r squared. And so if you want to predict, it's going to be the measure of the arc out of 360, because that's how we figure out what fraction that is. So that's our formula. And in this case, right here, I've got just a little sliver of a circle. I've got only 25 360ths of the circle. And pi times 6 squared would have been the area of the entire circle. And if you type all of that in, I like to just type it all in at once, and you should try that too. 25 divided by 360 times pi times 6 squared is 7.854. And that's an area. We always measure areas in squares, so square centimeters. That just tells me how many little squares it would take to fill that up, right? It would, oh, maybe I should have drawn those a little bigger because it's going to take almost 8 of them. almost 8 little square centimeters to fill that out. All right, and this last one, this one looks like more of a major arc sort of thing going on, right? It didn't give me really, okay, well, it gave me this 90-degree angle right here, but I'm not looking for this part that's missing. I'm looking for the part that's remaining. So can you figure out how much of an angle is in there? 360 minus 90 is how much would be left. So that's 270 degrees in there. So the area of this guy would be 270 degrees out of 360 degrees. That fraction of the entire circle, pi r squared. And just FYI, 270 over 360, if you reduce that, that's 3/4 of the circle. I just thought it was important to kind of see how that reduces to 3/4, and this is 3/4 of a circle. So 3/4 times pi times 5 squared, 58.905. And this one is measured in feet, only it's area, so it would be in square feet, which we can abbreviate like that. Let me know if you have questions.